Hi everyone, in this video I will walk through the interactive dashboard I built for the assignment 3 of data science and business intelligence. The dashboard is called the Netflix mobile app experience dashboard, and it is designed for the next Netflix executive leadership. In assignment 2, I analyzed about 5,000 Netflix mobile app reviews using natural language processing and trained logistic regression model with TF-IDF features to identify whether a review expressed dissatisfaction. However, those results were originally inside a Jupyter notebook, which is not the best format for exclusive decision making. In assignment 3 is about translating the technical analysis into a clear view on dashboard. The purpose of this dashboard is to help us quickly understand the customer's sentiment, identify the main drivers of dissatisfaction, and let me see the model result more clear. The dashboard is organized around four strategic questions that Netflix executive would care about. The first, how serious is the satisfaction in the mobile app review data? Second, what are the main drivers of dissatisfactions? Playback and uh, loading the problems, account issues, payment functions, update related complaints, or the customer care problems. Third, can the model reliability identify the dissatisfied users or what language pattern is it using? Fourth, how can Netflix use this type of model operationally, for example, to triage incoming reviews and route high-risk complaints to right product or support team? Every section of the dashboard maps back to one of these questions. This keeps the dashboard from becoming just a collection of charts. Instead, it creates a decision support tool that helps executives move from data to action. So the biggest design challenge in this project was to translating the assignment tools uh, into this hard to read uh, technical data into executive friendly output. In the assignment to proceed technical items such as IF/IDF terms, logistic regression coefficients, F1 score, and cross-validation results. These are useful for analysis, but not immediately meaningful to executive. So I made three transactions. First, I converted individual keyboard and diagram into business complaint themes, such as playback and loading issues, accounts and login or household issues, payment and subscription value updates, interference, customer care, and others. Second, I translated the model evaluation into simple KPI cards, especially recall, because catching dissatisfied users is important for Netflix. Third, I turned the model prediction into a dissatisfaction probability, so a decision maker can immediately understand whether a review is likely to be a complaint. I also clearly state that this is the dissatisfaction probability, not charm probability. And the dashboard layout is organized from high-level summary to the deeper exploration, which matches how C-suite's audience usually reads the dashboard. At the top, the executive summary section includes KPI and include the executive summaries include the KPI cards such as the total reviews, average rating, dissatisfied review percentage, negative review count, and model recall or F1 score. These are the number executive can understand within the first few seconds. Below the KPIs, I introduce a short executive interpretation. The key message is the Netflix mobile app reviews show a polarized dissatisfaction pattern, and the negative reviews contain more actionable details than positive reviews. On the sidebar, user can filter the dashboard by the rating range. Segment complaint theme, keyboard search, and the dissatisfaction risk sharehold. The layout is intentionally a simple, high-level KPI first, visual evidence, and second, the model details later, and the recommendations at the end. The main visualization are designed to be clear for a non-technical audience. The sentiment and rating overview sections include a rating distribution chart, a positive versus negative distribution chart, and a comparison of review lengths by the segment. One important finding from assignment 2 is that the negative reviews are longer, and the positive reviews average about 15.6 word, while negative reviews average about 27.2 words, which means dissatisfied users tend to explain their problems in more detail. The dissatisfaction driver section is the most important part for the action. It ranks the complaint themes by negative reviews volumes and show top negative keywords and phrases such as doesn't work, new update, Netflix account, and etc. I also include selected review examples so executives can connect the metrics back to the real voice of the customer. I avoid overloading the dashboard with too many charts because the goal is clarity, not the technical complexity. And the dashboard includes several meaningful interactive features. The rating range includes several the rating range allows the executive focus on the low rates reviews or compare them with high rated reviews. We can change the rating rates here, and the chart here would be different. And here is also can change the negative reviews. The segment drop-down lets users view in all reviews, negative reviews only or the positive reviews only, and the complaint themes multi-select allows users to isolate issues such as playback account, payment update, or customer care problems. The key search box lets the executive quickly test whether a specific issue appears in users' feedback. Finally, the risk sharehold sliders controls what counts as a high-risk review based on model probability. The important point is that these controls are not decorative and they update the KPIs charts and the review table so an executive can ask practical questions such as how many one-star payment related reviews do we have and what do users say about household issues. How many reviews would be flagged if risk sharehold were 70? The dashboard also integrates the assignment to model in an executive-friendly way. I show the key model metrics. Accuracy of 0.8383, the precision of 0.7619, recall of 9.9200, and F1 score of the 0.8353, and the five-fold cross-validation of validation F1 of 0.8183. I emphasize the recall because of the business risk is missing dissatisfied users who may represent cron risk. To avoid the black box feeling, the dashboard also shows the top terms that drive negative and positive predictions. Negative driving terms include money, bad, new, working, or this stuff, and the positive driving terms such as love, best, great, and amazing. Some words like this. There is also a prediction tool. Users can estimate the users can pass a simple review, click predict, and see whether the review is likely satisfied or the dissatisfied, along with the dissatisfaction. This is not a cron probability, and it is a model's estimate that reviews express dissatisfaction or not. Here we can see it detects this word is likely to be a negative review. And the dashboard ends with recommendations because the purpose is decision support, not just reporting. The first recommendation is to prioritize playback reliability, loading problems, and post-update quality assurance. The second is to audit account, household, payment, and customer care flows because this seems repeatedly appear in a dissatisfied feedback. The third is to track the value-related complaints, especially around the pricing or plan changes. The fourth is to monitor app reviews in real time after every major release. The fifth is to operationalize the NLP classifier to the higher NLP to optimize the NLP classifier so high-risk reviews can be routed automatically to the product, support, payment, or engineering teams. Each recommendation is tied to evidence in the dashboard. This helps the Netflix executives understand not only what the data says, but also what actions should follow. And finally, the dashboard includes a strengths and limitations section. Its strengths are that it turns assignment tools, NLP, and machine learning outputs into executive-friendly KPIs and visuals. It supports interactive exploration and makes the model interpretable rather than a black box. The limitations are also important. App Store's reviews are self-selected and may not represent all Netflix subscribers. The negative label is a dissatisfaction proxy, not an actual cron label. The dataset does not include device type, app version, subscription plan, region, or user-level cron outcomes. The model shows association, not causation. For product use, Netflix should combine review text with crash logs, support tickets, payment data, app version, and actual cron outcome. To summarize, the data dashboard turns a Netflix mobile app review dataset and an NLP classification model into an executive decision support tool. It shows what is happening, why users may be dissatisfied, and what model can predict and what Netflix should do next. Thank you.